Welcome to Learning Set 3, Lessons 8 through 11, Part 2, Test Review. So again, as I said in the first one, I've broken them down into two smaller videos, so it's not a longer video. And so we're going to go through the review. Again, as always, if you have any questions about the review, ask me in class. I'd be happy to go over any of the questions with you. So let's take a look at these questions right here. Which of the following does not represent energy being converted? Hold on one second. I'm going to grab a pen here so I can write and underline stuff. Okay. So which of the following does not, so I'm going to underline that, does not represent energy being converted? Stretching a rubber band, well, stretching a rubber band produces what type of energy? Does it produce elastic energy? Okay. How about dropping a ball? Well, if you're dropping it from a height, it's going to have some GE, and as it builds up speed, it's going to have KE as well. Playing with a yo-yo is going to go up and down, up and down, up and down, so that's going to have energy. So it's going to be a book sitting on a desk. Now be careful with this. A lot of people will take a look and say, well, Mr. Wittun, none of these work because at the nanoscopic level or at the microscopic level, it's got atoms that are moving and stuff, so it's got some KE, some kinetic energy. Well, when we talk about this, we're talking about the large level. So for example, if you're sitting in your chair and you're not moving at all, you don't have any KE. We're not necessarily talking about the atoms inside you moving. So it's not something you can do, if your mom complains that you're spending too much time just sitting downstairs and say, well, no, I'm not. I'm not just sitting here. I've got kinetic energy. And then you explain to your mom that your atoms are moving. I don't think she's going to be too impressed with that. So don't overthink this and say that none of them apply, because this definitely would apply under these situations. So down here I've got two springs. Spring 1 and spring 2 are identical. Okay. That'll come up in a second. They're identical springs. Spring 1 is pushed together a little bit more, or pushed together a little and clamped in place. Spring 2 is pushed together a lot and clamped in place. And I can definitely see that from here. This one definitely is pushed in a lot more. So which spring has more elastic energy? Spring 1, spring 2, both springs have the same energy, and you cannot tell unless you know what the springs are made of. Well, let's go back up here. They're both identical springs. So that really does not apply, because if they're both identical, it doesn't matter what they're made of. Now let me ask you this. If I took a rubber band, and maybe you've had this happen to you. If someone takes that rubber band up to you and they pull it back just a little bit and let it snap, is it going to hurt a lot? No. How about if they take that same rubber band and they pull it way back? Is it going to hurt more or less than if you pulled it back a little bit? If you're saying it's going to hurt a lot, if you pull it way back a lot more than if you just pull it a little bit, it's the same concept. If I push this spring way back, it's going to have more elastic energy. So it would definitely be spring 1, right? No. Look down here. Spring 2. So I'm going to circle that one. And I know both springs have the same energy. So it's definitely going to be spring 2 for that one. So any questions about that? Okay, so let's take a look at the next slide. Oops, sorry there, I dropped my pen. So this is something that I told you was going to be on the test. So this should definitely be no surprise. I didn't tell you exactly how it's going to be on the test. But what I did tell you is that you're going to have certain things, like a ball bouncing on the floor, a candle burning, a lit light bulb connected to a battery, two children moving up and down on a seesaw. You're going to have to figure out what type of energy transfers are happening. And then you're going to have to place them in here. Now, on the original test, I told you that this one right here was going to be used once. This one right here was going to be used 3 times. This one right here was going to be used twice. This one's going to be used twice. Now, in the retakes, I'm also going to do this. I'm going to make it a little bit easier for you. I'm going to have how many answers each one of these should have. And this should help you out tremendously, because then you know how many letters should be in each one. So, for example, I see a ball bouncing on the floor. Okay, is there any electrical energy there at all? No. Is there any chemical energy there at all? No. Is there any chemical to kinetic? Well, there's still no chemical. Is there any chemical to electrical? Well, there's still no chemical energy. So the only possible answer could be this one. So I'm going to put A here. Okay. So I'm only using it once. So I'm going to cross this off. I'm already done using it. Okay, I'm going to go down to the next one, a candle burning. Okay, so is there any electrical energy there? No, there isn't. Is there any chemical? Okay, it's burning, so there's going to be some chemical. So when you light a candle, does it give off light? Yes. So I'm definitely going to put a B here. So that's once. I know it's used twice more. Chemical to kinetic. I'm not sure about that one. Let's go down the list. Chemical to electrical. I'm not sure about that one either. How about kinetic to gravitational? Okay, so I'm gonna have to look. I'm not sure which one of these is. So let me take a look here. Okay, I've lit the candle, and if here's the candle. Okay, it's giving off light. I've already got that one. So what else is it giving? It's giving off heat. Okay, what's happening to that warm air? Is it rising? Okay, so we could technically say it's also this one and it's also this one because the kinetic energy, that heat is rising, and so which means it's going to have kinetic to gravitational energy. So as the heat rises, it's going to be converted from kinetic to gravitational. Okay, so I've got this one done. A lit light bulb connected to a battery. So it can be used twice. So, okay, it's connected to a battery. So I know it's probably going to have something to do with electrical. So I have electrical right here. Okay, so electrical to thermal. Does a light bulb give off thermal? What's thermal? Heat? What do you think? Is it going to give off heat? Absolutely. So it's definitely going to be this one. Now, I've got to come up with at least one more because I need to get two of them in there. Is it chemical to light? Well, you got the chemical in the battery. However, you got to go from chemical to electrical to light. So I'm not sure it's going to be that. How about from chemical to kinetic? Chemical to kinetic. I'm not sure. Well, one of the good strategies you can do is you can always come back to it and see what there is. Chemical to electrical. Wait a minute. When I went over here, we said that it went from chemical and then it produces electricity, which produces light. So could it go from chemical to electrical? Yep, this is my other one. Now, did you see what I did here? I went from one, and if I didn't know for sure, I left it blank and I was going to come back to it. Because a lot of times we don't look at all the different ones just to make sure. Now, I could look at this one too and say kinetic to gravitational. Nah, there's no kinetic motion here. Unless afterwards, when it releases some heat, you might have some chemical or some kinetic. Okay, so now I'm down to my last one. Now look here though. This one only has one answer. This one can only have one, so I'm done. This one can have one. Ooh, look at this. This one has two answers, and this one has three answers. So this should be D and D, but I'm going to test it to make sure. I don't want to, what if I made a mistake in one of the other ones? So I want to test it just to make sure. So, okay, two children moving up and down on a seesaw. Okay, so what do you think? How about this one? Do you think this works? Kinetic to gravitational? Well, let's look at this. What's happening? Okay, two children moving up and down on a seesaw. Okay, if this indeed is the case, could the argument be made that these kids, the way they get their energy is through their bodies, through their cells? So is it any different than the way you exercise? Where do you get your energy from? Well, you get it from your cells, which are burning, the food that you've eaten. So could it be chemical to kinetic? Okay, that makes sense. And it fits in here as being two possible answers. Well, how about kinetic to gravitational? So here, as the seesaw is moving up and down, you could say that the seesaw itself is kinetic to gravitational back and forth. So we could make the argument for these. So I hope not only did I review these with you, but I went over some of the strategies that you can use. Notice that I crossed things off. And then from here I said, okay, there's one answer, so it must be these, but I didn't just automatically put them. I double checked to see if they made sense as well. And I always like to think about some stuff. I don't want to just write down anything automatically if I see it. So let's look at our last slide here. Electrical energy is used to power a lamp. Is the amount of light energy, okay? It's underlined, so it's important for a reason. So it's light energy emitted by the lamp more than, less than, or the same as the amount of electrical energy used. Okay, now my first instinct to say, well, it's the same as, isn't it? Because you can't lose energy. Energy cannot be created nor destroyed. However, is the amount of light energy emitted by the lamp more than, less than, or the same as the amount of electrical energy? Ah, that's the key. It just says light energy. So I'm going to say less than. Now, explain your answer why. Well, if you have a light bulb, so if here's a light bulb, and here's, the part where you screw into the socket. Now, it's going to give off light, right? Lots of light. But light bulbs also give off what? They're going to give off light, but they're also going to give off some heat. So the light bulb will get rid of some heat as well. So all that electrical energy, sorry about my writing. I'm actually writing on a pad that's off to the side, so I'm looking at my screen, but I'm writing, my arm's fully extended. I'm trying to write way off to the side, so it's a little sloppy there. So you have electrical energy going in, and some of it's going to be used to light the light bulb, but a lot of it's also going to be given off as heat. So that's why it's going to be less than. And the last question, I told you directly was going to be on the test. Can light be considered a type of energy? Explain your answer. And the reason that you came up with in a book is that light energy can be converted to all different types of energy, right? We can convert it to electrical energy. Okay, and we can do that in your solar powered calculator. Light energy can, be used to do what else? Well, plants use light energy to create their own energy, right? So because light energy can be converted to other types of energy, we know that light itself is energy. Because again, you cannot create nor destroy energy. So if you're going to have electrical energy, that energy to supply the electrical energy, say in a solar powered calculator, had to come from somewhere. And in this case, it came from the light. So that does conclude part 2 of the review. Again, as always, if you have any questions, just make sure you ask me in class. I'd be happy to go over any of it with you. You just have to ask. So, but be sure you watch the video first, because it'll definitely help you study for the test as well as make your corrections for the retakes. Thanks. Bye.